Welcome to Study Loop.
To find the magnification of the bolt, we can use equation 25.2b, which says that if our eye is at near point, then the magnification should be equal to 1 plus n over f, n where n is the near point. So we can put the numbers here. So it's going to be 1 plus 25 centimeters divided by the focal length, which is 9.6 centimeter. So from here we get the magnification as 3.6x. Now we need to find the width of the bolt, and to do so we can first use equation. If we look at equation 23.3, we get a relation between the width or height of the image and the object with the distances of the image and object if we have a lens. And so if we so since we know our image distance, because our eye is at 25 centimeters, we can figure out our object distance, and from this equation, equation 23.8, and say if we can figure out our object distance, we can plug that number here, and we know that the bolt is 3.8 millimeters wide, which is our HO. So from there we can solve for HI, which is the width of the image of the bolt. So let's first try to find out the object distance. So that's going to be DO, which is equal to F of DI by DI minus F. Now, since the eye is at a near point, so our image distance should be negative. So our given focal point is 9.6 centimeter. Then we have negative 25 centimeter divided by 9.6 centimeter minus negative 25 centimeter. And that gives us the object distance as 6.94 centimeter. Okay, so now we know the object distance and image distance. So, and of course, we know the height or the width of the bolt. So let's find out HI from there. So from this equation, HI will be equal to negative HO times DI over DO. And if we plug in the numbers, HO is 3.8 millimeters, and DI is negative 25 centimeter. Actually, let's do it on the other page. So yeah, HI is negative of 3.8 millimeter times negative 25 centimeter divided by 6.94 centimeter. From here we get the width as 13.7 millimeter. Now there's another way to do this problem. So to do so, we can look at figure 25.17 text, and from there we see that magnification for small angles, magnification is equal to the height of the image divided by the height of the object. So this is for small angle. So from there we can also find HI, which is M times HO, and M we got as 3.6 and HO is 3.8 millimeter, and that gives us the same result. So that's one way to verify that we did it correctly. And for last part, we have already found the object distance, which is this quantity right here, 6.94 centimeter. So we can simply write that down, 6.94. centimeter. So that's the object distance. Thank you.